All right, guys, so here is what I want to do. I want to go over, I already did problem A. I want to do problem B right now. Let's see if I can get my stuff up and working for you. All right. We are going to do B, which is going to be liquid butane is used as a fuel to ignite a lighter and combusts. So if you take a look at the formula, we have C4H10, which is obviously a hydrocarbon, and it gives you a big hint as to the type of reaction. So I hope that all of you guys are screaming that it is a combustion reaction because you would be correct. So I'm going to put a C here, saying that it's a combustion reaction. Now let's go about writing this equation properly. So we are starting with liquid butane, which in the case of the formula, good thing for us, they give it to you, C4H10. And remember, it is combustion. So the definition of a combustion equation is a hydrocarbon in the presence of oxygen that makes carbon dioxide and water. Don't forget that. All right. So this is what the formula would look like. CO2 and water. Now we need to make sure that our formula looks correct. So if you take a look, some of you guys might be saying, yo, that looks right. Actually, it's incorrect. Some of you guys might remember this group of 7 elements that are extremely important that I call the Magnificent Seven, right? That can never exist by themselves. So we have one of them here in oxygen, so it cannot exist by itself. Make sure you put an O2 there. Now we need to talk about the rules for combustion. I'm going to write them right up here. So rules for combustion is, the first one is you're going to balance carbon first. The second rule is you are going to balance hydrogen next. And then for the third rule, you are going to balance, finally, oxygen. Okay? So let's go about doing it. First thing, we're going to balance carbon. Looks like I have 4 carbon on this side. I only have 1 on this side, so I need to put a 4 here. All right, done with that. Now we need to balance hydrogen. I have 10 hydrogens over here. I only have 2 over here. That means that I need a 5 right here. And then the last thing is going to be the balance oxygen. Now, oxygen is always going to be the tricky one. Let me get rid of these arrows so it will be a little less confusing for you. Okay, so the question that I want to ask you is, how many oxygens do we have that we need to balance? So we have 4 times 2, which is 8 oxygen here. And then we have 5 times 1, which is 5 oxygens here. Okay, so total oxygens that I need to balance, if you were to add them up, I'm hoping that you guys have remembered how to add. If you didn't, go ahead and take out your calculator. There's no shame if you need it. But 8 plus 5 is going to be 13 oxygen, right? So remember, on this side, I'm going to need 13 oxygen. Now, we have 2 over here, which is the problem. So you can either represent it as a decimal, or you can represent it as a fraction. I'm going to represent it as a fraction because it's easier for me. So I'm going to say that we have 13 over 2. Okay? So now that I have figured that out, let me erase all of this stuff. And now you need to remember that last rule in combustion. You cannot leave fractions or decimals. So in the case of having a fraction, if you remember, you are going to multiply all of your coefficients by 2. Okay, so let's do it. So I'm just going to change colors so you can see it. I won't get rid of it. Okay, so over here, we know that we have a coefficient of 1. That is going to become 2. When you multiply 13.2 by 2, you end up with 13. And then you're going to take your 4, you're going to multiply by 2, you're going to get 8. And then you're going to take your 5 and multiply by 2, and you are going to get 10. All right? So that is the balanced equation final answer. It is 2 C4H10, 13 O2, 8 carbon dioxide, and 10 water. Hopefully that was helpful.